Awesome. Okay, so like we talked about last time, right? So we have these neural networks, and what I'll do is I'll run through an example here so that we can have a better idea of how these things work. So we're going to start off with the concept of a city, and the city has 10 ice cream vendors, right? I'll try and mark some stuff here. Okay, so we have 10 ice cream vendors, and what we want to do is we want to predict the sales amounts for an ice cream vendor given some features, right? And we're gonna decide what kind of features that we're gonna look at here, okay? But we've got ice cream vendors, and we want to say, depending on some features, how much are they gonna sell? Okay. Let's take a look at a few of the features. So for example, maybe we look at the location of the vendor, right? Maybe they're next to a park and you're going to sell more ice cream near a park than maybe you are just in the middle of, some intersection at a street. Maybe the pricing of the ice cream, right? Maybe you'll be able to sell more if your ice cream is perhaps maybe a little bit cheaper than some of the competitors, right? And we'll also look at the variety of the ice cream that's offered. So these are three of the features that we're going to think about in terms of how it affects sales price. So let's look at each one, right? So location, obviously, we talked about if people maybe can walk to get the ice cream, they'll have more potential customers, right? Because if it's close by and you can just walk, you don't have to drive or anything like that, you could get more people. Maybe you're talking about pricing, right? So if there's something that's more affordable, you're likely to sell more, as well as offerings, right? So if you can offer more flavors, maybe that'll get a larger amount of customers, right? Because people don't always like the same flavors, right? Some people like mint, some people just like regular chocolate. Some people like more of the fruity flavors, right? So like strawberry, things like that. So that could be something. So these are all things we have to think about, okay? And there are some indirect factors that we don't really think about as well. And any of those indirect ones we'll talk about as the hidden layers, right? We talked about we have inputs, we have outputs, and then everything that's happening in between is this hidden layer nonsense. So let's kind of scroll down and let's put all this into a neural network, right? So this is a nice little picture putting all that in. So remember, we talked about location, we talked about price, and we talked about the offerings that they give, right? What flavors? Those are our inputs, right? And the output is going to be the sales, right? How much are you able to sell at each vendor? And the hidden layer is going to include, so hidden layer, it's going to include some of the stuff that, aren't things that we just think about right away. So for example, number of people that walk by, right? That's not necessarily a input, right? A feature, because depending on the day, or maybe if there's an event happening nearby, you might have more people than others, than other days and things like that. So that's kind of like a hidden layer feature, right? You don't really know what's happening with that, but it might be affecting the amount of sales. Affordability might be kind of one of those hidden layer aspects. Perceived quality might be another one, right? So maybe one vendor looks like it's more high class than another vendor, right? That might not be something that we think about as a feature, right? Because it's very subjective, right? One person thinks, oh, this looks like kind of a rundown place, whereas other people kind of find value in that. So that would go in the hidden layer, right? There's certain aspects that we can't really measure per se, but they are contributing some weights, right? And so this would be it. This would be kind of our neural network, right? We'd have these inputs. We've got some hidden layer action going on with some other properties that we don't really know how to measure too well. And then we get the output, which is just the sales for the ice cream vendors. And of course, this is a specific example, but we could generalize it, right? So we did that kind of before we took our break, and we talked about, this is the input layer. And once we input all the data, it kind of goes through this hidden layer, and we have biases and we have weights and we have activation functions, a bunch of stuff happens, and then we're outputting all of that data together, right? It all gets summed up, and then we get one final output, right? So all the data comes back in and we get one single output, which is the sales price in our last example. Okay. So you could have any number of inputs, right? So here we have 1, 2, 3 inputs. You could have any number of inputs, right? You could also have any number of hidden layers. So in this example, there's only 2, but like I said, you could stack on hundreds of thousands if you wanted to, or you could just do very small amounts. There's benefits to both. And of course, we always get our single output. Okay, you could have several nodes in the output layer if you wanted to. But in this case, we only care about one thing, and it's the sales. So we're only putting one output. So that's the basics of our neural networks. And, you can think of some uses of this, not just, ice cream, but there's some other uses. So for example, here's a column of, input data X, and then what the output would be Y. So for example, if you put features of an ice cream shop in, you might be able to get the sales as the output, right? If you put pictures of dogs and cats in, you might be able to get a classification. Is it a cat or is it a dog, right? Maybe you put pictures of presidents. You can figure out which president it is, right? Neural networks can solve things like that. You're able also to, for example, if you put in some foreign language text, in this case, they put Dutch, but it could be anything, right? You could put Japanese text, you could put Chinese text, any language at all. It might be able to convert it to English text. And of course, the usual, right? If you put audio, text, and you can also put, in this case, you can't really do the other way, right? So if you put in text, you can't just generate audio. That, at least not in how we understand neural networks now as input versus output, but you could do a combination of things to create the reverse. But these are just a bunch of examples of how we can use neural networks. And there are certain types of neural networks. For example, the one we just discussed is a pretty we call it standard neural network, just regular neural network. There's things like convolutional neural networks, which are great with images or video. So any of that, any media files, really. You've got recurrent neural networks, which are great for audio or text. And then you've got some other things, right? Generative adversarial networks, things like that. These are a lot more complex models that we're not going to discuss. But if you do kind of dive deeper into neural networks, these things are very, very useful in a lot of the work that people are doing today. Okay. A nice little link that I would suggest playing around with if you have the time is here. So it's a TensorFlow link, and I can show it really quickly, but we're not going to actually click through and all. But what you can do is you can add in different parts of the data. You can train the training and test percentages. You can add features, hidden layers, and things like that. And what you can do is you can run your model, and it'll start to learn the data, right? So hopefully you saw that. I'll restart it again. Let's say I maybe add another feature in, right? Let's add that. And maybe I'll add another hidden layer. And we run that. So after some time, it'll start to learn the separation between the orange and the blue. Okay. So it's a fun little website. You can mess around, add different features, add different layers, and see how that affects your model. But like I said, we don't really have a lot of time, so I'm not going to click through there. And then there's some code at the end. If anyone does want to work with neural networks, you could click through some of this. This is for the breast cancer data that I was talking about earlier. So indicating if a tumor is malignant or benign, right? That was the example I used early on today. So what you do is you go through some of the data. Here's just some features of the data I printed out so you can understand it better. I do the train test split. Remember I talked about how you want to split your data up. So sklearn has a nice little function called train test split that you can just put your data in and it'll split it. So you can do that. Remember I talked about scaling your features as well. The sklearn also has a nice function. It's called standard scaler. You can just import that and that'll be able to scale your data. So here I do scale.fit, the training data, so it'll scale my data. And then what I do is I set up a multi-layer perceptron. So remember, perceptrons are the building blocks of a neural network. So this basically just means a neural network. So you can set it up. You can talk about the hidden layers. This is just some features I put in. You train it, and then you can make predictions. So here, if I predicted it, ones would tell us, am I malignant or am I benign? Okay. So it's very easy, right? You can see this code is very simple. You don't have to go through all this complicated work to set up neural networks. You can set up these things pretty fast, pretty easy, just by using sklearn. Okay, and then some last but not least, you can print out some statistics that you can look at. So for example, I can print out a confusion matrix. If anyone has seen those, it tells me out of all of the ones I said were, for example, benign, were they actually benign, or did I incorrectly classify them? Were the ones I said were malignant, are they actually malignant, or did I misclassify those? And then you can get precision, accuracy, things like that from a classification report. So these are all functions that you can just call in from sklearn and really just type in the data. Okay. Like I said, we don't have time to work through all of this, but if you do want to mess around with some neural networks, I suggest you take a look at some of this code, as well as what Ashan went through yesterday. I think those are some two great resources for you to get your hands on. Okay. So we'll finish up there. Like I said, wrapping up, we already took our break. So what we're going to do is let's take a look at our lab and let's see how we can implement k-means. Okay. So here's our lab. I sent the link in the Slack, but if no one has it, I'm going to send it one more time. So let's send this in chat. Remember, everyone has to download this to their computer. You won't be able to type in on this file. So that's for the lab. You also are going to need to make sure you get the data. So I shared a link to the data sets as well. So I'll copy this link and I'll send that to everyone as well. So you need to download these two things, okay? And so what we're going to do in this lab is it's pretty much going to be everyone working independently to try and complete these, but you can work as a group. So I'm going to make breakout rooms. And I want everyone to kind of collectively help each other out. But the end goal is hopefully you can do some of this on your own, right? I want you to get practice with working with Python. I want you to get practice using sklearn and implementing some of these algorithms, right? K-means specifically here. So that's what we're doing today. Here's a link to the data set as well. I sent it in the chat, but you're going to need to download it. So really quickly, if I just show you what the data sets look like, you've got these 5 files. Remember, once you download them, you have to go over here to the files section and you have to upload them, right? So you have to put the files in here. So what I'm gonna do is I'm gonna click on this. And then what I wanna do is I'm gonna wanna pull some files. So here I wanna go to data sets and I wanna pull all these files from what you downloaded in. Okay. So here we go, I got all my files. And once you have those, what you can do is, for example, there's a few exercises that we're gonna work through. I want you to look at exercise number 1, that'll be the beginning. And so exercise number 1, as you can see, we're looking for clusters visually. So you're gonna plot data and you're gonna try and see where your clusters would go. So here's some stuff. First, I import some data for you. So remember, this is the file over here, ch1 ex1, right? Chapter 1, example 1. And I'm just gonna load the values in. Then from here, there's kind of some steps which I try and guide you. So here I want you to import, this is matplotlib, right? pyplot. So you need to import that. You can look at some of the class code to see. So for example, right, we, import matplotlib pyplot here. So you can, right, this is what you would do for that second step, right? So you can copy that in, put that here. Then you want to create an array that contains these points, right? So all of this is kind of word for word what I want you to do. And now I just want you to turn it into Python text. Okay, can you code this stuff up? And like I said, of course, if you have any issues, I'm going to put us in breakout rooms. Hopefully everyone can kind of give some feedback, help each other to answer these. If you do need help, feel free to just message in the chat. I'll be jumping around the rooms. I don't know who else from the teaching staff that I have here. I have Daniel, but I don't know if there's enough of us. So if you do need any specific help, please let us know. We'll jump around and try and answer any questions. Okay, but these exercises are all very straightforward. Okay, so I'm going to try and give you as much text as possible, and I'm trying to get you to just get comfortable writing this in Python. So here, importing k-means from sklearn cluster package, right? So hopefully you can be able to type that. Use k-means to create a model with 3 clusters. Again, right, hopefully the code from class can help you a little bit with this, and so on. Okay, so let's jump in. I'm going to make the breakout rooms really quickly. And like I said, try and get going through this. Let's see how much we can get through, and if we can, get comfortable with coding this up in Python. Okay, so I'm going to stop sharing my screen. Everyone should have the link by now. And let me make these breakout rooms. We're going to do 3 breakout rooms. I think that'll work out perfectly for us. So here we go. And like I said, we'll check in with you, see how it's going. Perfect. So everyone is back. So what I'm going to do is we'll work kind of exercise by exercise, right? Of course, if you're moving a little bit faster, you can go ahead. But what I'll do is I'll give us some time. We'll work on exercise 1, and of course, I'll bring you back, and then we'll go exercise 2. I'll bring you back, go over it, just so no one's kind of falling behind, right? I want to make sure that we're slowly progressing towards finishing these up by the end of today. So let me share my screen, and let's talk about our exercise 1. I think everyone should have had a good amount of time to at least get going on this. So let's take a peek, right? Remember, again, we loaded in our data, and then from here, the first thing I said was, let's import pyplot. So remember how we do that? It's going to be import matplotlib.pyplot as PLT, right? So remember, we're just going to kind of create an abbreviation for this function. So anytime I write PLT, I'll be calling the plot function. Then I want to create an array called x. So x equals, right? This will be x. That's going to contain all the points in the first column, right? So column 0. So that'll be x equals points, all the rows, the first column. Right? So very straightforward. We just want to put all of these points in my array x. And I want to do a similar thing where I put the column 1 into the array y. So we'll do y equals points, all the rows, and then the second column, but this is the 1, right? Because 0 is the first index. That's the first column. That's the second. So let's run these. Let me just, right, I'll import this. I'll run x. I need to run that first, right? So points should have saved. Y will be saved there as well. And then I want to make a scatter plot. So we can create a scatter plot by doing plt.scatter, right? So remember, I kind of gave us a hint here. And if you're using some of the code from lecture, what you'll be able to see is that you just have to put in the x and the y values, right? So you can create a scatter plot with just the x and y values. I can run that, and it'll create an object. In this case, it actually already prints it, but if you do plt.show, usually that'll display it as well. Okay, so in this case, it's actually plotting already on this one. Usually it only creates the figure. But there you go. Okay, so this is our data. It's got, 3 clusters, or what it appears to be 3 clusters, right? I don't want to say it is 3 clusters, but it might be 3 clusters. All right, and that should be everything for the first step. So all we wanted to do was visualize our clusters, right? Print them out, see what we're working with. Does anyone have any questions with this? Any issues with maybe plotting, or are we all good?
I can't get like the files to upload to Google Colab, like all the ones that we.
Okay, so the uploading is not working. Does anyone else have this issue? I'll try and when we go back to breakout rooms, I'll come with you again and we'll try and figure that out. But is anyone else experiencing that issue?
Not.
Yeah, I am, but it was just with the downloading it from Google Drive, not uploading it to Colab.
So you had issues, or you figured it out?
Yeah, I had issues, but I fixed it.
Okay.
I just need to upload it to Google Colab now.
Gotcha. Yeah, so make sure you upload it right, because we're going to be using these X and Y values again in some of the other exercises. Okay, perfect. So if no one else has any other issues, we'll kind of move on to exercise 2, which is now we want to cluster the data. Okay, so now we want to start using k-means, stat function, and fitting and predicting the data with that. Okay, so back to breakout rooms. I'll give us about 5 to 10 minutes to try and do this one. Okay, so there is only about 7 steps, and most of them are just repeating, right? So you use the predict again, things like that. So back to breakout rooms. I'll give us 5 to 10 minutes. Any questions, message us. Daniel and I will jump around and we'll try and answer anything. And then we'll come back after that, discuss exercise 2. Perfect. All right, back to our breakout rooms. All right, perfect. So everyone should be back from the breakout rooms. Hopefully that went well. I know this kind of took a step up, right? It got a little bit more complicated than just plotting some data. So let's work through this. Hopefully we can finish this up, and then what we'll do is we'll work on breakout rooms until the break in 10 minutes, so at 2:30, and then I'll call everyone back. If we don't finish exercise 3, that's okay. We'll have more time after the break to keep working. But let's make sure everyone is at least good up to exercise 2. So remember, after I've looked at my data, right, I've visualized, I've scatter plotted it. Now I want to cluster. Okay, so what I've done is I've loaded the data, and I've also loaded some new data as well. First thing I want to do is I want to import my k-means. So remember, import, we're going to use the sklearn packet. So sklearn cluster, and then we'll put from this import k-means, right? This is very similar to the code I put in the lecture, Google Colab. So here I've imported sklearn, right? And I've gotten my k-means function. Now I want to use the k-means function to create a k-means instance. So I'm going to create a model that's going to call k-means, and I want to find 3 clusters. To specify the number of clusters, right? So I've kind of given us here, we used n clusters keyword. So n clusters, and you set this equal to what you want, which is 3. Okay, so what I do is I call k-means with 3 clusters, and I'm going to set it equal to my model. Okay, so I ran that. We're good to go. And then remember, once you have a model, you got to fit it to your data, right? We got to basically train it. So use the fit method of model to fit the model to the points. So what I do is I take my model, I do dot fit, right? I use the fit method, and I'm going to fit it on what data. So what do I input? I input points, right? Because I want to fit my model to the points I previously had. So I run that, and here we go, right? So it says some of the features of my k-means algorithm, right? So you don't really need to know all of these, but number of clusters is the important one. You've got max iterations, we've got some tolerance, things like that. So these are all the features of my model. Then I'm going to use the predict method on my model. So of course, again, we do a model.predict. And I want to predict the clusterings of my points. So again, what am I going to predict on? Well, I'm going to predict on points. And I want to assign this to labels, right? So you want to save this as labels. Oops, that's not labels, labels. Okay, so labels is going to equal the prediction that my model gives me, which is the labels, right? So let me run that. And right now you can't see it, right? I didn't print it out. I just saved them as labels, but you could print out the labels now and have a look at what they look like. So here, if I want to just print it out, of course you can just simply write print labels. So I print those out. Here we go. So what you can see is that for the first data point, I get a cluster of 2, cluster of 1, cluster of 0, 0, 1, 1, and so on. So those are all my predictions. And then last but not least, we're going to use the predict model, the predict method again on my model to do it for the new points. Remember, we took 2 data points. One of them was for the first function, and then I called something new points, which was for the second file. So this is different data. So let's do that again. Let's do our model.predict, but let's do it on the new points, not the old points, the new points. And I'm going to assign that to be new labels. Okay, so new labels will equal the prediction from my new points. And if I run that, that'll be good. And remember, here we're using the k-means model from the first set of data to predict labels for the second data, right? So you don't have to, use the same chunk of data to make the prediction, right? So in this case, I'm assuming the second data maybe is pretty similar to the first data, right? The patterns are the same. It doesn't have to be the same data, but the data has to be very similar in terms of the layout of the points, right? Because if you fit a model on one data and then the other data is way different, and then you just run the model on that, it's not going to perform well, right? So I'm assuming these 2 data sets are very similar to each other, okay? And if you wanted to, just really quickly, I'm going to print out my new labels and see how they compare to the other ones. So here, it looks probably fine. I would have to maybe scatter plot this to see for sure, right? So plt.scatter, and then my points, remember all 0, and then maybe points all 1, and I'll have to
points,
actually
right?
change this new points. Yeah, I just new points. And then maybe I run that. Oh, didn't close my parentheses, run that. And I'm still messing up because there's a parentheses here. Okay. And so, right, this was the second data. And remember, the first data we plotted was somewhere up here, which is that. So it looks like the clusters are about the same, right? There's maybe less data in the second, but the clusters look like they're in about the same region. So I predict that my model would probably still do pretty well with this. And so there we go, right? So hopefully this helped everyone a bit. I know that not everyone has experience in Python. So let's take the time here. So, we only have 3 more minutes before break. Does anyone ask any questions about any of the code we wrote here? Any questions about understanding the data, understanding the model we're using? Any questions at all? We'll do an open forum for the last few minutes. Okay. So, right, if no one has any questions, that's okay. While everyone's thinking of something, if they have it, let's just talk about what we're going to do when we come back from the break. So again, we do have some more exercises to do. So obviously we've only talked about exercises 1 and 2, but we've made good progress, right? We've been able to look at the data by using scatter plots, and then we've been able to call our k-means function and actually cluster the data points. Okay, so we've done good stuff so far, but we still have plenty more to do, right? So we've got a few more exercises. What I want to focus on coming back is particularly I want to inspect the clusters we've made. So here we're going to work on making a scatter plot and actually showing the clusterings we've made. Okay, so we have some code where we can walk through and set up the clusters for that. This might take some work, and so what we'll have us do is we'll all, as a teaching staff, jump around and hopefully help you a bit if you run into problems here. But we're going to inspect our clusters, and then we're going to try and figure out this with some real world data. So what we'll do is I'll import some seeds. So this is from the data set that we have here, right? So seeds. And what we're going to try and do is determine how many clusters should I use. Okay. So we're going to run through some steps and try and use a technique that some people use to try and identify the best number of clusters that we can take. So that'll be an interesting thing. We'll work through some of that code. And then once you do that, you can evaluate those clusters, of course, right? So it's very similar stuff to what we did before. Import k-means, make some predictions, get our labels, things like that. So very similar to what we've been working on. And then we'll work with some fish data, kind of do the same exact thing. So maybe we can scale our fish data down using our standardization methods in sklearn, cluster the fish. And then if we have time, we might not, but this last little bit, we can actually use clustering to tell which stocks move with each other. So if we have a bunch of stocks that all increase or decrease together, we kind of want to find that pattern and cluster them together. So I don't know if we'll get there, but that's something to look forward to. So we'll take our break now. We'll do our 30 minutes, and then hopefully everyone comes back at 3 ready to go, and we'll work through some more exercises. If there are any questions, feel free to stick around. If not, I'll see everyone in 30 minutes. So I'm glad everyone's back. What we're going to do today is I'm going to take a second just to talk about some information for the final project, clear that up, and then we'll jump right back into some of the exercises we were talking about earlier. Okay. So let's share my screen, and I'll kind of show you a rubric that we've set up. You can take a read through it. So essentially what we're looking for is for each student to present their work. This can be relatively short, okay, only about 5 to 10 minutes. It doesn't have to be anything big and crazy. And what we'll do is we'll have a little Q&A section at the end, just so we as instructors and some of the other students can ask you about your work. And there's some logistics here. So if you feel comfortable pre-recording it, that is also okay. So you can pre-record and then, you know, just make sure that you give us the link, and we'll be able to you know, play it out and share our screen or something so everyone can see it. Okay. If this is your method, just let us know. We have to do a little bit of planning to make that happen, but perfect. And then what we'll do is we'll have everyone provide feedback for at least 3 other students. So everyone who will be presenting will have to take their 3 assigned students and fill out a little bit of a rubric. We're going to do this through a Google form, which we will send later on. And it's just some basic questions. And it would be important for you to look through this rubric because this is what you're being graded on. So you can make sure to have that in your presentation as well. But some pretty straightforward things like, were you able to find your data set and can you load it in Python? Are you able to kind of visualize this data and give us meaningful feedback on what the data really means? Can you normalize your data if you need to? If you don't, explain why you didn't have to normalize it. And then some things about, choosing a reasonable model. So if you're trying to do a clustering task, you should be choosing a model that can do clustering. So explain why you chose the model, train it, talk about any parameters that you had to use for training. So for example, if you're using k-means, talk about some of the cluster numberings, right? So you have to choose the number of clusters for that algorithm. So talk about how you kind of decided to choose that number and things like that. And then a few other things. So talking about, how well your model performs, maybe error, loss, whatever you want to use as a metric. And then just some things about the presentation itself. Are you able to clearly articulate what you did? Talking loud, making sure we understand you. Were you organized? Does your presentation have a nice flow to it? And then were you able to answer any questions that people, gave you? So, we're grading on kind of a bigger picture. Okay. So it's not just, was your project really good, right? We want to see, are you taking something away from the course? Can you work in Python? Do you have an understanding of why you chose these things? And can you present well, right? Everything is going to be about, even if you have the best project, if you can't clearly show us that you have the best project, that means something, right? As you move forward, and if you're going to go into higher education, especially, we want to make sure that you can clearly explain what's going on. Okay. You want to make things easy for people to understand. That way they can really see the impact of your work. All right. Here's a little timeline really quickly. Monday yesterday. So you talked with Sean about, data sets, things like that. So hopefully you're kind of getting down and really choosing a data set that you want to work with. Today, hopefully you can start to begin using some of the algorithms we've talked about. So, putting your data in there, seeing if you want to do a certain task, right? Regression, clustering, classification, whatever it is. Tomorrow, hopefully you just continue kind of working on that, putting some work together. Thursday will likely be a bulk of the work. So Dr. Harley will be back and he'll give everyone some time to work on the project in class. So you'll be able to kind of put everything together there and we'll be there to answer any questions. And then of course, Friday, we're going to present. Okay. And then, the schedule we talked about, we'll probably set up a schedule already and we'll probably post it by Thursday just so everyone knows who you're going to be, grading for the rubrics, who's going to be presenting when, things like that. So we'll send more information as the week progresses on all of that. But important to have this rubric. We'll send the link in the Slack as well so everyone can look at this again. Okay. But I just wanted to quickly preview this, let everyone know what we are going to be looking for. Does anyone have any questions with this, the rubric and the project in general before we move on to what we were talking about earlier today? Okay, perfect. So it seems like no questions. Again, if you do, just feel free to let us know. We're going to go to the breakout rooms now, so you can also ask in the breakout rooms about that. But let's shift back into our k-means mode. And what we're going to do is we're going to jump back in on exercise 3. Okay, remember I previewed this before we took a break. We're going to work on inspecting these clusters. Okay, so we're going to start to kind of load everything in, make some scatter plots, and see if we can figure out where these centers of each cluster are. Okay, let me set up these breakout rooms again. I'll send everyone there and let's get working. Perfect. Okay, they should be open now. All right, perfect. So everyone should be back. Let's just quickly walk through exercise 3. Okay, hopefully everyone made good progress and finished it. If not, that's okay. We're going to go through the steps now. So here we go. So we'll start from the beginning, right? So what I did is we've already have some text written out or some code that will load in the data set. So we'll run this. And of course, we'll run some of the code from our previous section, which was just setting up k-means, putting 3 clusters in and fitting our model. So we'll run that. Now, of course, I'm going to import matplotlib. So you can recycle this from before, right? So import matplotlib.pyplot as plt. And we want to assign column 0 of points to xs, column 1 points to ys. We've already done that, right? That's again something we did above. We just called it x and y. So I'll just do xs equals points, all the rows, the 0th column, and then ys equals same thing. And we'll run that. Now we want to make a scatter plot. So we've also already done this, right? But in this case, now we're specifying the c equals label argument. And what this is going to do is this is going to color the points by their cluster label, right? So remember, we got clusters 0, 1, and 2, which corresponds to the 3 clusters in our model. And we're going to now color them based on if they're 0, 1, or 2. So how do we do that? Well, same thing, right? I do plt.scatter. This is how we typically made a scatter plot. You're going to put your x values and your y values, right? You have to put in your data. And then last but not least, we're going to use what we talked about, right? C equals labels as our coloring scheme. And so if I run that, I get a nice plot like this. Okay, and hopefully everyone was able to get this. Here we go. These are our clusters, right? So this is looking awesome. But we want to go one step further. Okay, so the clusters are good, but let's add the center in. Remember, we talked about clusters have a centroid. There's a middle point that sets up the entire circle that forms the cluster. So let's plot those as well. How are we going to get that on the graph? Well, we got a few steps. So step 6 says, let's get the centers, right? Get the location of the clusters of the centroids by using the dot cluster centers method. Okay, so I'm going to take my model. Okay. And once I have my model, I'm going to do dot clusters centers. And remember, I want to assign this to centroids. So I'm going to do centroids equals the cluster centers, right? Model.cluster centers. So we'll run this. So I've saved their locations. And now I want to assign column 0 to centroids to column x. Or sorry, centroids x. So let's do that here. I'm going to set that. I'm going to do y. Same thing. And remember, now I want to do this for all the rows and the 0th column. And then I want to do the same thing, all the rows, the first column. So this is very similar to what we just did up above, right? I took the points and I took the first column, which are the x values, the second column, which is the y values. I'm doing the same thing with the centroids, where the first column is the x value of the centroid. The second column is the y value of the centroid. Okay. So nothing too tricky here. We'll run these lines. And now in a single cell, I want to plot kind of both scatter plots, right? I want to plot the original scatter plot, which was this up here, plus the new kind of points for the centroids. So let's take this and copy it over and plot it. So that'll create the first graph. Let's also plot the centroids for the x and y location, right? So we'll take this, the x centroid locations, we'll take the y centroid locations. And then what we can do is we actually want to add in a few other parameters. So if you read here, we're going to use x to mark the points, right? So instead of using circles like we've done up here, I want to create X's for the centers. The way you do that is you specify the marker parameter. So remember the parameter, you write it out, marker, and I can set it equal to, in this case, I want to set it equal to X, right? So I want to make them X markers. And I also want to set the size of these to be 200. So it says here, just use S equals 200. Okay, so that'll just set the size of the markers that we use, the X values. And then I can just graph it, right? This should work if I run this. And there we go. Okay. So what we see is that the clusters are exactly how we printed before, but now you can see the center of each cluster with a big X, right? So perfect. This is kind of building up to what we did in class. Right? Remember we talked about there's a centroid, and the algorithm kind of slowly moves it to center in on all of our data. Okay. Awesome. So that is our exercise 3. Does anyone have any questions with any of that code we did, or I guess any concept we had here? Okay. Perfect. So if no questions, we're going to jump again back into our breakout room, and we're going to just keep going on, right? So hopefully everyone has this written down. You were able to run this. Now we're going to go to exercise 4. And exercise 4 is talking about how many clusters are we going to need to use. Okay. So let's break out again. If you have any questions, one of us will be able to help you. We're all going to be in a room. So let's get back to it. So everyone should be back. Let me share my screen. We'll kind of get moving on this. And hopefully we can maybe do at least one more exercise before we have to finish up for today, if not 2. So really quickly, right? So we're talking about grain now. So we've got this data called seeds, and I've loaded it in for you, and we kind of have deleted one column. So there's a column called grain variety. I deleted it. We're going to talk about that maybe a little bit later if we get to it, but this is kind of a nice little problem that we work with pandas. So we talked about pandas last week. So this could be a nice little practice. And what I want to do is just step 2, just to inspect this data frame, right? Display it and take a look. So we know that you can just print it out, right? So seeds df, if you just print it just like this and I run this, well, I got to run the first block first, right? So if I run this, what you get is this nice little chunk here, right? So it shows the area, the perimeter, compactness, length, right? So I have all these columns. This is looking good. Notice that there's 7 columns, which means that our data is in 7D space, right? There's 7 dimensions. So if you were to scatter plot this, it wouldn't work, right? You can't really scatter plot in 7D. Scatter plots work nicely for 2D cases. I mean, you could probably make a scatter plot in a 3D, which could provide some information, but 7D, it's too much. Okay. Now from here, you want to extract measurements using the dot values attribute, right? So what you can do is maybe we can take some samples, right? And we can say, okay, that's my data frame seeds dot values. Okay, so dot values is just going to pull all of that there. And then what I'll do is I'll actually just print this out so everyone can see. So if I run that, you get a big array that pulls 15, 14.82, all of these, and it just makes it the first row. And then I go the next row, I pull the next bit of data. So all we're doing is pulling the actual numbers out of it, right? I don't want to create the nice little data frame. I just want to take the raw numbers. And then I actually, unfortunately, didn't include this in the original download, so that's on me, but I had sent everyone the code. So hopefully you were able to put this in. All I'm basically doing is creating K values from 1 to 6. So this will just create a range of numbers from 1 to 6, 1, 2, 3, 4, 5. And then what I do is I create a loop where I change K. So I go K is 1, run the code. K is 2, run the code, and so on. And so I create a cluster with that number, and then I run k-means for that cluster, and then I fit the data and I find the inertia. So what we were doing in the beginning was basically, we didn't know how many clusters we wanted, but a way we can find it is by looking at the inertia graph. So there's this technique where if you look at the inertia graph, there's a little elbow point, which can tell us the best number of clusters. So that's what we're aiming towards. And so if you run this code, we can get some inertia values. And then I just want to plot the inertia. So how am I going to do this? We're going to import matplotlib as PLT, and then I'm going to plot it, right? So PLT plot, I'm going to plot the K values. I'm going to plot the inertia values, and maybe I'll create some zeros, right? So that's how it'll print. I'll do PLT X label. Maybe I should have also put this on here, but this kind of could be a good review of plotting. So number of clusters, we'll call it K. And then the Y label is going to be just inertia, right? So you should always put an X and Y axis on your plots. And then let's do PLT X ticks. Let's see what that looks like. Invalid syntax. It's because I spelled it wrong. Okay, perfect. So if I run all of that, I'm able to create my plot. And then what we see is that I get this nice graph. And so the idea here is that you're getting this point over here, which is what we consider this elbow. So they call it, right? It's the elbow. And so the elbow is where we are going to define the best number of clusters. So right now, the optimal number of clusters we see is going to be 3, because that's where the point where the inertia begins to decrease a bit more slowly. Okay, so this is like that sweet spot. This is like the prime number we want. Okay. This might have been a little tricky, especially towards the end, right? So we had to work on plotting a little bit, but hopefully you got most of it done, if not all of it, with some help from some of our staff. But perfect. Okay, so it's 3:42 Eastern right now. We might be able to do hopefully one more exercise, maybe even 2, but let's jump into exercise 5 and let's see if we can evaluate these clusters now. Okay, so take a look through. Everything should be done. I think the only thing that wasn't included might have been this for step 5. So really quickly, I'm going to send that in chat to everyone. So make sure to add that in to your step 5. And I'm going to put us in breakout rooms. Okay. Perfect. Let's do it. Okay. Awesome. I think we're all back now. So like I said, I really quickly want to just go over this because the last exercise 6, talks about us scaling our feature, the data, right? Scaling our features. And so I think that'll be really useful for some people on the final project. So I really want to make sure we cover that. So I'm going to go a little bit fast. If you have any questions, just let me know, but I'm going to try and get through this as quickly as possible. So let's take a peek. Hopefully you read this a little bit. So we identified from the inertia graph last exercise that 3 clusters is best. And the data actually is from 3 clusters, right? We have 3 different grain types. And what we don't do here is just cluster them like we've normally been doing. So what I do is I load in my data, I set my samples. I want to import from sklearn.cluster. I want to import k-means, okay? And then I want to create a model with k-means where number of clusters is equal to 3, okay? So again, all pretty straightforward stuff that we've already done in the past. So you should be able to at least run this code. we're going to use the prediction, right? So we're going to do labels. Actually, I want to create samples, don't I? Yeah, so let's do labels equals my model dot fit predict on my samples. So fit predict is basically the same as calling them both at the same time, right? They've kind of made a nice function to put them together. So I call it on my samples and I label them as labels. Run that. Here, I sent this code to everyone. So basically, I'm just going to create a pandas data frame where I've got one labels column and one varieties column. And what I'll do is I'll print out the data frame for us. So if I do that, you've got the labels here, and then you've got the variety of that seed here. Then I want to use this function called crosstab. This is actually really nice. What it's going to do is it's going to basically give me the number of times that each variety shows up. So let me just put this in here. So all you do is call PD for pandas crosstab, and then you put in your 2 data frames, and then I'm going to run this, right? Run that, and then I'm going to display it. And so what you see here is for each label, right, for each cluster, you can see how many of each variety is in there. So cluster 2 looked like it almost was able to get all of the Canadian wheat. Cluster 1 almost got all of the camo wheat, and then cluster 0 almost got all the rosa, right? So it's obviously not perfect. We do have some misclassifications here, but it's looking good for the most part, okay? Awesome. So does anyone have any questions with that before we try and do the last exercise? I know we're running a little bit out of time, but I think if we switch over now, we might be able to get enough. Any questions?
Zachary, do you want to do the next exercise yourself instead of going into breakout rooms and maybe just explain it all yourself?
Yeah, that might actually be beneficial. So why don't I do that? If anyone does, want a little extra practice, you can always try and solve this again on your own. But like I said, I think this will be helpful for a lot of people on the final project. So let me work through this a bit. So essentially, we're going to load in some fish data. So everyone should have this data set already uploaded. And each fish has some information such as the weight, the length, the ratio of length to width, and different things. And so what we want to do is we want to standardize all those features because we know obviously weight is different from a length and all of that. So let's do this. So first things first is we're going to load the data, and I already kind of wrote this, so I'm going to run it. We're going to call the data frame .head so that the head function is just going to show us the first few. It's like a preview. It shows us the first few parts of our data frame. Okay. So I got this nice preview. It shows me the first 5. So I've got weight, length for 3 of these, and then I've got height, and then I've got width. Okay. What I want to do here is I want to extract all the measurements to a NumPy array, which is very simply using the dot values, right? We did this in a past exercise, right? You can just call the data frame, do dot values. And so I'll do samples equals data frame dot values. And I can actually print out the sample as well. So if I do this and I run this, you see I'll be able to get all of these written out in just a NumPy array. Okay. So hopefully everyone's following so far. That should be a pretty straightforward approach. And then what we're going to do is, and I might want to try and minimize this. I want to just perform some imports. So make pipeline from here. So really you can just do, right, from this import make pipeline from sklearn, right? So you just got to kind of type some of this out. But what we're doing is we're importing pipeline, we're importing the standard scalar, which is what we're going to use to standardize, and then from sklearn.clusters. Oh, we can import k-means. Now remember, some of these you already did. So for example, I already imported k-means quite a bit in this Google Colab. So you don't necessarily have to write this every time. I'm just putting this into a good mindset of uploading or importing the packages whenever we need them. So let's create an instance of standard scalar called scalar. So what I'll do is I'll set scalar equal to, and then I'll type standard scalar. And one of the nice things about Google Colab, as you can see, is it kind of gives me some of the suggestions already. So here I just click tab and I can see the suggestion filled out for me. So I can run that. Then I want to create an instance of k-means. So k-means equals k-means with number of clusters equal to 4. Okay, that's exactly what we've done in the past. And I also want to make a pipeline called pipeline. So pipeline equals make pipeline. And what it says, it wants me to chain together scalar and k-means. So all you got to do is put scalar and k-means here, and that'll kind of chain them together. Okay. So I'll run that. And now what we've done is we've set it up to transform all of our data and perform the clustering. So really quickly, if you take a look here, what we've done is, this is the code from the past, right? So you made the scalar, you made the k-means, and you made the pipeline. And what you're going to do is you're going to fit the pipeline to the samples, right?
Can you go back up to the pipeline code really quickly?
Yeah. So that here is the same as this one down here.
Okay, thank you.
And so what you want to do here is basically you want to fit the pipeline to the fish samples. So remember, we can take pipeline.fit. Okay, this is exactly what we've been doing. And you just put in the samples. And we might want to call this something. We might want to call this like, I don't know. I'll just call it fit samples, right? This is just something for me to view, and then you can run it like that. So this is an actual object, right, that we have. So we can run that. And then you can obtain the clusters and things like that by running your predict on here. So pipeline.predict samples, and then I can call that labels. Okay, so again, a lot of the same stuff is repeating. So you can do that. And then you can perform the same operations as before. So what I'll do is we'll probably take a break here. Right? There is a few more bits of code that you can type in. It's the same exact code from the previous exercise, just rewritten to be for this specific data set. But what you would do is you would display your crosstabs, and then some further examples are just working with this again. So I'm going to upload these solutions for everyone to see. So if you'd like to go through and, for example, see your data being normalized and things like that, you can take a look at the code. But we are running out of some time, so we will finish off there for today. Okay. And here I put kind of a funny little picture. So it says, "Dear Andy, how have you been? Your mother and I are fine. We miss you. Please sign off your computer and come downstairs for something to eat. Love, Dad." So just a little joke. Hopefully you took something away from today. Like I said, I'm going to send in Slack the recordings for today. I'm also going to send the solutions to these exercises. So if you'd like to take a look, feel free to browse there. If you have any questions on, any of this code or on your final project, make sure you're messaging in Slack. Okay. We're all there ready to help. So any questions at all, shoot us a message and we'll help out. Okay. Perfect. All right. Well, thanks for coming today. We'll see you tomorrow.